Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to working over here on the 10EE project. I really want to try to get this machine back together now that I got all my electronics sorted out, and we can start using this machine in the shop, hopefully when we get it reassembled, put back together. Before I do though, I really have debated on how deep I want to get into this project. You know, this machine, I feel like hasn't seen a tremendous amount of use just looking at it, but I've got the saddle off, the compound off. I mean, basically the apron, everything up here is off of it. If I want to check this machine out, now is the time to do it. And I know how to inspect one of these lathes, see how true the ways are, inspect the saddle, just start looking at things and getting an idea of how much wear there is in the machine and getting an idea as to does it make sense to come in here and do anything to try to fix it up. Now, you know, I could take this bed off and have it reground. I'm not going to do that. Whatever this bed is what this bed's going to be. I'm just not going to go that far down the rabbit hole on this particular machine. And honestly, I don't think that it's going to be necessary, again, just looking at it, but we'll know better once we do an inspection. The saddle that fits up on here, though, that's a little bit different. That is something that we could do some modifications to and do some tuning up to if we feel like we need to. And again, we're going to do some inspection and see how much wear is in it and then come up with a game plan if necessary. Now, as far as wear in a bed on a lathe, most any old lathe is going to have wear in them. Typically what happens is most of your wear happens up close to the headstock because that's where the lathe is mostly used, and it comes from the saddle just moving back and forth. You got the friction between the two surfaces rubbing up against one another, and yeah, they're going to wear. The more the machine's used, the more wear there's going to be in it. How important is that? Well, with the wear that happens in here, typically what's going to happen lots of things are happening, but what's important to note is that when it's wearing, it's typically going to wear down. You know, your left to right being on a V-way, it's going to typically stay, you know, pretty much on that V-way, because as it wears, it's going to be self-correcting, but it will drop down a little bit. What impact does that have on the accuracy of the lathe? Well, you know, if this bed drops down, say 3/1000ths of an inch, it's not like it's going to affect the diameter of your work by 3/1000ths of an inch. If you think about it, your cutter's coming into your work here, and if it drops down, straight down 3/1000ths of an inch, yes, that part is curving around, so it's cutting a little bit on the low side of that rather than right on the center, and as you go out, move out farther out the end, that cutter's going to be raising up just a little bit. But it's a tiny fraction of the drop in the cutter as far as the diameter of the work. So typically speaking, you know, unless you've got a pretty significant amount of wear in a lathe, it may not make sense to send it out and have it reground. You know, if you're doing super high precision work, you know, you're making parts for NASA, yeah, you might need to, but for general stuff that's going on, probably not that important. So anyway, I'm not going to make any judgments until we get a chance to kind of look at some numbers on this and get an idea of what's going on, but I can tell you that just from a financial standpoint, and I really don't want to have to take the machine farther apart to send the bed off and all that, unless we just find something really stupid, crazy wrong with this thing. I'm not planning on going down that route. I might eat my words once we look at it, but I don't think I will. So let's see what it's going to take to do some inspecting on this lathe and get an idea of what the bed looks like. So before I can really start inspecting the bed on this lathe, the first thing I need to do is get the lathe leveled up. And this lathe did not have any leveling feet on it when I got it, but I went around and looked, and there's 4 tapped holes up underneath the bottom that looks like it's for leveling screws. They're tapped 1/2 inch 13, so I got some leveling feet here. Just ordered these from McMaster Car. They're swivel, but they're on a 4-inch threaded post. They're cushioned on the bottom for vibration control, and these will basically just sit on the floor, and you can adjust these up and down independently to level your machine out, which is important on a lathe. These are rated for about 3,500 pounds per pad, and that's going to be more than enough to support this lathe. This lathe is not going to be anywhere close to the added up value of these, or even half of them. So we should be within range. So let me kind of get it down up underneath it. I'm going to get these threaded up in those holes, and we'll start to get this thing leveled out. So let me get down here, reach up underneath here and find those threaded holes. It is, and I'm going to have to get this raised up just a smidgen more to get clearance. Let me get my pallet jack in there. So I wasn't quite high enough to get clearance here, so I just got my pallet jack up underneath it. Now these are high enough to get the thread started, hopefully. All right, that's got that one started. I'm gonna get it on up in there a few turns. I wanna leave these long enough that I can get up underneath this with my pallet jack and pick the whole machine up. And I'm also noticing that that's not a through hole, so it doesn't go all the way up through the casting, so it's not going to let me go. I want to leave enough room in there to be able to have some adjustment on it. So I'll go ahead and get this other one in. All right, those are about the same height. So now I'm going to lower my pallet jack down, and we'll have to pick up the other side and get it done. All right, we now have this machine up on leveling feet, and now the process begins of getting the bed leveled. And it needs to be done in two directions, long ways and across ways. And to just kind of start out with, I'm going to just take a Starrett 98 machinist level. This one is accurate to about, I think, 5 thousandths per foot, 3 thousandths per foot, something like that. It's going to get me close. I'm going to get it roughly leveled in, and from there we'll go to a more accurate level to fine tune it. Now I can tell just by looking at it that the back end is up a little bit higher than the front, so we need to lower this down. I'm just going to crawl up underneath there. We'll start adjusting screws, and once I kind of get it leveled in this direction, we'll flip our level around the other direction and check it in a couple places to get it as close as we can with the resolution of this level, and then we'll get out our precision level, our more precision level. This one isn't precision level, but we get one a little bit more accurate and fine tune it. So let me get to work twisting some knobs. It's not rocket science, guys. You just turn those little knobs around and adjust things out until you get it level, and we'll do that first. So to finish this leveling job out, I got out my fell all-way level. This is an extremely accurate level. Each line in here represents a 0.5 thousandths per foot. So very, very fine increments. You breathe on this wrong and it moves that level around. And I've got it within half a bubble on the up and down. The side to side is dead nuts. This way, like I said, half a bubble. I'm just, if I breathe on it, it's going to move. So trust me, you know, just working on this machine is going to cause it to be out more than that. This is extremely level right now, and level enough to do the test that we're going to be doing. I've got it sitting up on some 1, 2, 3 blocks using the flats on the lathe. These should be at the same height. So that's just the best surface I got to go off of. Again, is it absolutely perfect? Probably not, but it's closer than you're going to get with even a standard machinist level, a standard Stanley 98. So it's good enough for what we're doing. Let's do some inspecting work on these ways. So with the lathe all leveled up, and I did actually come back and double check this with a second level. My Starrett, was it 199 or the super precision Starrett level that's accurate to 0.5 thousandths per foot. I went back and double checked it along with the fail level, and they both checked out. We're level in both planes, or pretty darn close to it, close enough to it that it's not going to matter for the tests that we're doing. So now what I've got on here is this Kingway alignment tool. This is a tool for measuring changes in bed measurements. Now, we're going to assume that this bed has worn because it's a used machine. All machines are going to wear over time. We know, generally speaking, on lathes that most of the work is done up close to the headstock. So that's where the saddle is working most of its time, is right in this area. So typically you're going to see your worst wear right in this area. On this Monarch lathe, these ways are hardened. So they're cast iron. This is a special cast iron that has a fair amount of carbon in them, and they actually have a flame hardening process where it just hardens the ways. It's kind of case hardening, just the ways up here, and then they grind everything in. So because of that, the wear should be less on the ways than it is on the saddle. The saddle's just cast iron, it's softer metal. That's where most of your wear should take place. But reality is you're going to get some wear in here. The question is how much, and that's what this tool is going to be able to measure. So I've got it set up right now where the front edge is riding on the way. So it's basically sitting up on the surfaces just like the saddle's going to ride on that surface. There's a kind of a notch down here in the bottom that it rides on there. And then I also got it sitting on this flat back way. This flat back way is the same side that the saddle's going to run on. So the saddle's going to run on this way in the back. You got a way in the center here and a flat here. That is what the tailstock runs on. That's a whole separate thing. So we're concentrated right now on just these outside ones because that's what the actual saddle is running on. And on this Kingway tool, there is a precision level on here as well. This level, even more finicky and accurate than the Starrett Master Precision level. The Starrett Master Precision level, the increments on there measure a 1/2 thousandth per foot. So what that means is if you were to take 12 inches and you were to put a 1,000th inch shim up underneath one end of that, it would move 2 lines on the bubble. That's 2/2 thousandths is 1,000th. So that's basically how you're measuring this. This level on here actually is measuring 0.0003 thousandths of an inch per foot. So 3 10,000ths of an inch per foot. Now to complicate matters even a little bit more, because our 2 points here are not 12 inches apart, they're 9.5 inches apart, you got to do a little bit of math to calculate what these measurements actually will be. So you take the 0.0003, you divide that by 12, which is how many inches is in a foot. I'm going off of inches here. And then I measure this as 9.5 inches. You multiply that times 9.5, and in this case, it came out to a little less than 1/4 of a thousandth per foot. So 0.0002375 is what each line on the bubble is measuring. And that's measuring how much it's raising or lowering. And again, we've checked the levelness according to the flats. So really, because I've got it leveled on this back flat back here, which is the side that this one's running on, what we're measuring when we run this down is how much this end is dropping down as you go, or raising up, but in reality, we're dropping down is what we're going to be doing here as we go along here. It's going to be dropping as it moves down. So I've got it set here on zeros, and what I want to do is I'm just going to right now, I think I'm going to just measure the maximum. I've already ran it up and down, and I can tell that it's kind of gradually dropping as you go through this process. We can come map it out, and I may do that later, but right now I just want to kind of see what the maximum is and figure out how much that side is dropping down. So again, I see where my line is. We're going to slide this whole thing down to the end down here. I'm gonna let that level settle out. I'm gonna count how many lines it moves on the bubble. And we did move a fair amount. Let's see, that's 1, 2, 3, 4, 5, 6, 7. It moved 8 lines. 8 lines. Sounds like a lot, but remember that's a very accurate level. So again, 0.002375 per line. I'm gonna multiply that times 8, which is how many we moved, and 1.9 thousandths of an inch. So let's just say 2 thousandths. So my way has worn where as you get down here, it's dropping down 2 thousandths of an inch from one end to the other. Sounds like a lot again, but we got to look at some more math to see how that's actually going to affect what you're turning. And it's not going to be 2 thousandths on the diameter. It's going to be much less than that because your tool is dropping. It's not moving in or out. It's dropping straight down, relatively straight down. So bottom line, this isn't bad. Is it perfect? No, it's not perfect, but it's not bad either. It's going to be, for the work that I'm doing, it's going to be fine. I should be able to turn parts on here. And, you know, if I have something really long, I may have, you know, troubles keeping it in 10 thousandths, but as far as turning to 1,000th of an inch, should be fine. So that's good news. We can do some further testing on this if we wanted to. We can actually come in here with indicators and measure off the front and the back of the way and try to map this out even more. But I'm mainly interested in what the maximum difference is, because down on this end of the lathe where we set things up, this is where the least amount of wear is. This is where the most amount of wear is. So we're just kind of looking at the maximum here. So guys, I know the question is going to ask, well, how much difference in the diameter, the radius of your work will dropping the cutter 1.9 thousandths of an inch matter? So I thought about it. I said, well, we can figure that out, kind of drawing out a triangle here. So here's an example. I just said, okay, let's just say we're doing something that has a 2-inch radius. That's a 4-inch diameter. We're turning a part with a 4-inch diameter, which on a lathe like this, that's a realistic expectation. And so you got 2 inches from the center to right here, where your cutter is. Well, if you drop that down 0.0019 inches, which is what the bedways are dropping down, I drew this out as a right triangle, and I want to figure out what the hypotenuse of this right triangle would be. That's going to be the new length for what you're turning by your cutter dropping down. So I took, just using Pythagorean theorem, a squared plus b squared equals c squared, where the c is the hypotenuse. So 2 squared plus 0.0019 square, that comes out to 4.000000361. You take the square root of that. So instead of being 2 inches, it's going to be 2.000000902. So, you know, again, remember, this is your thousandths, this is your 10 thousandths. So, you know, we're talking, what is that, a millionth of an inch? Less than? Bottom line is, guys, is this has virtually zero impact on the diameter of the part that we're turning, at least, again, at the level of precision that I'm working with. I'm not going to say it might not be important for some people. And remember, too, that if, you know, assuming that's a constant drop from one end to the other, this is happening over, let's just say 2 feet, 24 inches. So, you know, very seldom are you even going to be turning something that entire length on the lathe. Very, very little impact on the accuracy of what the machine will do. So is that worth me sending this off and having the bed reground? In this case, I say the answer is no. Well, there you go, guys. I mean, that's kind of just looking at the bed. Like I said from the beginning, I wasn't planning on doing anything to it anyway, but looking at this, very, very usable like it is right now. You know, the question then comes, you know, if you're looking at your lathe, how much of a drop in that elevation is enough to warrant having the bed reground. Well, just keep in mind, you know, as that's dropping down, the effect on the diameter is going to increase exponentially because remember it's curving out as it goes around. So, you know, the first couple of thousandths, it has very little impact. Then it starts having a bigger impact and a greater and greater impact. So, you know, you'd have to do the math and figure out exactly what it's going to be for your particular situation. But, you know, if you've got a lathe bed that has 3, 4, 5 thousandths drop in it, you know, that's probably still, in most cases, that is probably still usable and acceptable. But at some point in there, you know, if you're shooting for accuracy, you want to put the time and effort into it and doing it, it does become, you know, more of a realistic thing to say, okay, yeah, I'm going to spend the money to increase the accuracy of my lathe. And again, you'd have to do the math and figure it out for your situation based on the wear that's in your machine. But for this machine, it's just, in my opinion, it's just not worth it. So I'm not gonna do it. All right, I'm gonna get the Kingway tool, put it up for now, and now I want to start inspecting the actual saddle that goes on here, because even though this wear is minimal, it's very likely that the wear in the saddle is greater, again, because that metal is soft cast iron versus hardened cast iron. So there's some wear here, but the amount of wear in the saddle is going to be many times greater theoretically than the wear that you have in the bed on a lathe with hardened ways. So let's start taking a look at that and seeing how much wear is in there, and again, whether it's worth going to the trouble to rebuild that saddle or just let it roll like it is. So this is the bottom of the saddle that goes on here. This is what rides on the ways on the machine. So this is the front way. This is the one that fits up on the V. This is the back way. This just rides on the flat back there. And what I want to do is clean this up, make sure we're good and clean, and start making some measurements to see how much wear is in these parts. And again, decide, is it worth coming in here, possibly machining these, putting some turkite back in them to build them back up. I did this when I did my 16-inch Monarch lathe. When I restored it, it had a significant amount of wear in the saddle itself, and we decided to just go ahead and machine it out and fix it. We didn't do the ways, but we did do the saddle. I'm going to take a look at this one. I'm hoping this one's in better shape. I'm not going to require it, but if it does, we'll deal with it. So I'm going to start by just putting a little bit of WD-40 on here, and I'm just going to take a Scotch-Brite pad, and I'm just cleaning right now, just trying to make sure we got all the dirt and trash, oil, gunk, whatever might be built up on this. I just want to get it out of there so that when we're making measurements, we're making good measurements. And these are in pretty good shape. Again, just looking at them, they're in good shape. I don't see any just immediate red flags going off. There's a little bit of paint that got right there. I need to get off. This little area right here is what mates up to the apron up underneath the bottom. And this is going to be a good reference surface for us to work off of, and I'm going to talk about that here in just a second. But, you know, the first thing I'm looking at is I know where my wear surfaces are. This is a wear surface, this is a wear surface. Then I've got other surfaces that are not wear surfaces. They were all machined when this was new. Would have been machined at the same time, would have been done in the same operation. So you can use those as reference surfaces when you start making measurements. So for example, this surface here will be a really good reference surface because it was machined. You can even see where there was a little bit of scraping done on here, and to make sure those two faces really matched up with one another. But that is a basically untouched surface. It's been clamped together while this machine has been together, so there's virtually no wear in that surface at all. Back here on the back, we got the bottom of this piece here. You can see this was actually, I can see that's the original planer marks on there where this was machined on a metal planer. You can see the long parallel marks, but this surface, even though it's been exposed, it's not a wear surface. It's not something that has like been rubbed up against or something's been working against it. So this is a surface that it may not be as pristine as this one, but it's going to be good enough that we can actually make measurements from this surface to this surface and compare them and get an idea of how much wear is in here. And that's exactly what we're going to do. Is right now we're basically making comparative measurements to see the relative amount of wear. Now I can't tell, you know, exactly how much wear has happened in these two surfaces because I don't have, well, I might be able to, because right here, for example, if you look, you can see a line right here. And on the back side of that line, that was machined when it was new. And that was probably, I mean, that's pretty much a, maybe not perfectly untouched surface, but you know, we can measure the height of that compared to the height of the one right behind it and get an idea of how much wear this has gone down over time. Up on the front way here, it's going to be a little more difficult to do that because there's really nothing there we can measure. Now on my 16-inch Monarch, there was actually a ridge that had worn right here in the bottom right here where it had kind of gone down, that we were actually able to measure that. I don't see a ridge in this one at all. And basically what that is that, you know, when this was machined new, that came out flush, but as it wore down, it kind of wore a little ridge in it. But again, I don't see that. I don't feel a ridge in here at all, which is a good sign. That means that, again, that there may not be a lot of wear. All right, I'm going to start, I think, on this back surface. I'm going to get a depth micrometer, and we're going to measure the depth from here down to the bottom and measure it across here and see what kind of differences there are. I would expect there to be more wear on this side than on this side. This is the side that is facing the chuck. This is going to be flipped over. So this is the side that's facing the chuck. So you got the downward work pressure on this side, whereas this side is just kind of out behind it. So you don't have that as much work pressure over here. So theoretically, there should be more wear here than here. We'll see if that works out. We'll probably see that on the front way when we start measuring it too. But again, hopefully not much wear. So we're going to start up here on the front end. I'm going to go to about the middle of this flat. And I'm just going to measure the distance from this, my reference surfaces up here. These are comparative measurements. You know, ideally they're all going to be the same. In reality, they probably won't. That's about 8/19. I'm just going to call out 19 because they shouldn't vary more than a couple of thousandths. So I'm going to call that 19. I'm going to call that 19. $18. 18. And so again, about a thousandths deeper on this end than this end. Not bad. I can live with that. Let's measure the front side. This one's going to be a little more complicated, but I got a way to do it. So what I'm interested in measuring here, guys, is I want to measure the up and down variability in this way. We know that it's going to have some wear in it. It's going to be variable from one end to the other. By how much is what we want to know. And not so much side to side, but up and down. So we're going to use this surface again as a reference surface, and we're going to make comparative measurements to the height of the way. And the way I'm going to do that is I've just got a gauge pin. This is a very highly precision ground pin. This one happens to be 0.730 inches, 730 thousandths diameter. And what I'm after is I'm after a diameter where this is hitting roughly about halfway on either side in that way. And that's just going to kind of give me something that's going to sit down in here. This will be, again, be a reference point. And I'm going to take, in this case, I've got a dial indicator set up here on a surface plate block that I can run on this surface back here. And we can just sweep across this. And again, I'm doing comparative measurements. I really don't care what the measurement is. I just want to know how they relate to one another, what the difference is from the highest to the lowest point in here. So we're just going to take this, and we'll sweep across, and I'm just going to set a 0. And we're about a 10,000th of an inch high right there. Now I'm about a 10,000th low. This is aggravating. All right, I'm going to call that 0. It's not exactly 0, but it's 50 millionths of an inch. Close enough for what we're going to do. So we're just going to kind of come down through here. I'm just going to go down a little ways. We'll sweep back across that. And if anything, it's about 50 millionths of an inch. What is that? That's going to be higher there. Let's hit it right here and see what it is. So we're about 4/10 low right there. About a 1/2 thou high right there. Maybe about 2/10. So the big thing that I'm getting on here, and again, I could go in here and spend a lot of time really mapping this out and writing numbers down on here. But from the highest point to the lowest point that I measured, about a 1,000th of an inch. So again, we showed that a while ago. Is that going to have any impact on the accuracy of this lathe? Virtually 0. And again, in this case, it's probably, the low spots probably aren't even touching. So when you look at points of contact, it's probably less than a thou, or it will be less than a thou difference across there. So bottom line, am I going to fool with this? I think the answer is we're just going to leave it alone. I think it's good enough. But we're not through testing the saddle. There's also the cross slide I wanted to do some tests on, and I've already gone in here and made some measurements, and I'll show you what we did. So 2 different things. First off, I wanted to measure these outside areas, the bottom sections. That is the wear where the cross slide goes across this. Again, you would expect most of the wear to be back in here because the cross slide very seldom gets pulled all the way up, or probably all the way out to the back. So anyway, I wanted to measure that. So the top surface here, while arguably it's not a pristine surface, this is not a wear surface. There's nothing that rubs against that routinely, although in reality there probably is a tiny amount of wear in there, but this is more or less a reference surface that we can measure off of. So I just took a depth micrometer, and I just went in here and I measured the depth from the top of this to the bottom. Again, relative measurements. This should be in the plane with everything else. So, and it should be relatively, I'm not going to say it is untouched, but it should be good enough for a reference surface. And I wrote the measurements down. And what I did is if it was reading 7 point something on the micrometer. So I wrote down, if it was 7.5 thousandths, I wrote down 75. That tells me 7.5 thousandths. So a 75, it's not 75 thousandths, it's 7.5 thousandths is the way that works out. And so I basically look at my smallest measurement and my largest measurement, and from that I can tell how much variability there is in the height of these different places. The smallest measurement I got was right here at 7 thousandths. The biggest measurement I got was right here at 12 thousandths. So that's 5 thousandths wear in this. So it's 5 thousandths deeper there than there. I think on this side, 75 was the smallest one. So 4.5 thousandths on this side. This one, 70 and 98. So let's just round that up to 10. So that's 3 thousandths variability. So is that enough to be concerned about? It's a judgment call. This is fairly easy to scrape. I come in here with a straight edge. I get one side done, then I basically get the other side flat and parallel to the top here. I think I'm going to go ahead and scrape those in. Now, while I was at it, I also wanted to check, you got dovetails on this. I wanted to check how if the thickness of this varied. So again, similar to before, I took a couple of gauge pins. These are the gauge pins that, again, roughly touch about halfway up on the dovetail. And I just took a micrometer, it's like this right here, and I measured across that. And again, I just measured whatever the measurement was on the micrometer. I just read it was 15.2, 15.5, 15.0, and so on, measuring the width here. And again, that tells me how much it's worn on the dovetail side, and it is considerably less. I see 155 was the widest it was, so 15.5 thousandths compared to 137 was the smallest. So again, let's just round our tenths to the closest. So let's just say 13.5 and 15.5, so that's what, 2 thousandths. Not a lot, but a little bit of variability. So, when we're scraping this out, it'd be fairly easy to go ahead and just get this side. And what happens is that, again, this is where your less wear is. There's more wear in here. So as this goes in, it gets a little bit narrower and then kind of, well, actually in this case, it doesn't come back out. So this is pretty much constant down to about right in here, and then it starts getting a little bit wider and a little bit wider, but less than 2 thousandths. Again, probably, it's not terrible, but fairly easy to fix. I think we're going to scrape that in, and then we'll scrape the cross slide to match it as well and get this tuned up. It's a judgment call here. This probably would be fine to leave as it is, but again, I think I'm just gonna, it's relatively, it'll probably take me 4 or 5 hours to do this, and it'll make the lathe, it won't be, it'll be tight and loose as I'm using it. That should all be very nice and flowingly even. And from an accuracy standpoint, that little bit of drop in elevation is probably not going to matter, but it'll just make it run smoother. So I'm going to take the effort to do that. Well, there you go, guys. A quick and dirty just inspection of this while it's apart. Easy to just go ahead and do it. And again, in summary, the bed, not perfect, but not bad at all. And the amount of improvement in accuracy that we get on this machine from spending a bunch of time and money to fix it, not worth it. The saddle, pretty much same story. It's, we could spend some time scraping it in and improve it a little bit. It's just not worth the effort. The cross slide, yeah, it's not bad, but I think this does warrant taking some time to do a little bit of scraping and get it tuned, so I think we will do that. And I will say that once we get this scraped in, one of the tests that we will then do is also test it to make sure that this is running perpendicular to the ways. And at that time, we may possibly have to do a little bit of scraping to the saddle to kind of correct any, if it's off one way or the other. We won't know until we get this done first. But if we have to make a little adjustment, we'll go ahead and while we're scraping the bottom of the saddle, we can improve it and make it fit a little bit better. But as it is right now, just not worth the effort. But it may end up getting touched. It may not, just depending on what our geometry looks like on the cross slide once we get that done. So with that, that's a wrap for this episode. I hope you enjoyed this. It isn't every day that you're at a place where you can do these kinds of inspections. You got to pretty much take the whole saddle and everything off of the lathe to do this kind of inspection. So, you know, while we had it there, we're doing it. And good news is that it's in pretty darn good shape. So I'm happy with that. Guys, we're going to sign off there. As always, thanks for watching. Please subscribe if you haven't already. Thumbs up, those comments, they really help out a lot. Please leave them. Please leave that thumbs up. Again, take the effort. It really helps me if you do that. Big, huge thank you to those who help support the site financially through Patreon, PayPal, and YouTube memberships. Those are all ways that you can just go a little above and beyond and help support financially. Even if it's just $1 or $2 a month, if enough of you guys do that, it really does make a big difference. And the guys that are doing it, you are making a difference. And I appreciate the people that are doing that. With that, guys, we're going to sign off. We'll catch you on the next video. Again, as always, thanks for watching.